The fundamental theorem of calculus, part 1. Let f be a continuous function on a closed interval from a to b. The function I, defined by I of x equals the integral from a to x of f of t dt, has the properties that it is continuous on a to b and differentiable on a to b. Moreover, for all x in the interval a to b, the derivative of I of x, I prime of x, equals the derivative with respect to x of the integral from a to x of f of t dt, which equals f of x. Remember that we saw in the introduction to the fundamental theorem of calculus that the derivative and the integral, which we noticed to be the antiderivative, are inverse processes of each other. So taking the derivative of the antiderivative, or the derivative of the integral, cancels out, and we're left with just that function that was the integrand. For example, in number 1, when we are asked to evaluate d dx, the derivative with respect to x, of the integral from 2 to x of square root of 1 plus t squared dt, it is simply just the derivative cancels out the antiderivative. We replace the variable t with the variable x, and that is the square root of 1 plus x squared. Just that. Look at example number 2. For capital F of x equals the definite integral from 5 to x of 1 over 3t squared dt, find part A, capital F of 5. Well, because capital F of x is defined as this integral, we replace the x with 5. So this is the integral from 5 to 5 instead of 5 to x of 1 over 3t squared dt. But of course, because this is an integral from 5 to 5, it is going nowhere and creating 0 net area. This time, we are finding in part B capital F prime of x. That means we are taking the derivative of the capital F function. So let's write this as the derivative with respect to x of that capital F function, the integral from 5 to x of 1 over 3t squared dt. Because we are taking the derivative of an antiderivative, these are inverse processes, and we are left with simply the integrand with the x plugged in, 1 over 3x squared. Part C, capital F prime of 2. In part B, we just found capital F prime of x, and now we plug the 2 in for the x. So we take the x out and substitute 2 in its place, and this evaluates to 1/12. Number 3, find capital F prime of x if capital F of x equals the integral from negative pi over 3 to x cubed of cosine t dt. So capital F prime of x equals the derivative with respect to x of the integral negative pi over 3 to x cubed of cosine t dt. Now again, we're taking the derivative of an antiderivative. These are inverse processes and therefore cancel out. But notice that this time, what we have to plug in is not just x. It will be x cubed inside this function, or rather creating a composite function. And when we take the derivative of a composite function, we must use the chain rule. Remember what that looks like. We have the inside function as it is, x cubed, and we must multiply by the derivative of that inside function, 3x squared. Now this is a fine final answer, but it can be cleaned up just a bit by putting 3x squared in front of cosine x cubed.